and welcome to today's webinar, Lighten Your Batch Jobs Burdens. I'm Julie, and I'll be your host. I am joined by Dr. Maitreya Natu, our Chief Scientist and a very valuable member of the igneous incubation team based in Pune, India. Good evening and welcome, Maitreya.
Thank you, Julie.
Maitreya's research interests include network management, network security, big data analytics, and next-generation enterprise IT systems. He is an active researcher in the systems and networking research community and has published more than 50 papers in international conferences and journals. He is also on the technical program committee and organizing committee of various national and international conferences, and is also an adjunct faculty at the Indian Institute of Technology. Today, Maitreya will be sharing how you can lighten your batch jobs burdens. Our hope is that you will walk away knowing how you can manage even the largest and most complex batch jobs smoothly. But before we get started, I do want to let you know that we will be saving time towards the end of the presentation for your questions. So if throughout the webinar you have a question, please feel free to submit it in the question box and click send. Okay. Let's get started. Maitreya, over to you.
Thanks for the introduction, Julie. Hello all. Thanks for joining this session. Today I'm going to talk about our core philosophy behind building this product of managing batch jobs using igneous, and what problems we are trying to address, what are our aspirations behind building this product, and what are the capabilities the product has today. So I hope you can see my screen on the WebEx. So there are three key pain areas that are common across all batch job systems across various environments that we have seen. First is high complexity and noise. Traditionally, in almost all medium and large batch systems, you see complexity and heterogeneity as a big challenge. There are different schedulers, there are a large number of jobs, wide variety of dependencies cutting across business units, geographies, and so on, which becomes a big challenge in introducing transparency in these systems. Another challenge is noise, that typically you get large number of alerts. Mostly these are like large number of false max run alarms, false min run alarms, and that happens because there is insufficient transparency into the batch operations and leading to inaccurate alert configurations and noisy alerts. Another common problem is surprises. Unexpected outages, unexpected delays, unexpected SLA violations is a very common symptom in batch systems. And one of the primary reasons to see these is resolver or support team's inability to prioritize actions. When a job fails, it is very difficult to assess the impact of that failure because the underlying dependencies and the scale of those dependencies is pretty high, and usually that visibility is not available. And because the prioritization is insufficient, this leads to insufficient time to take corrective actions. Last but not the least, there is also a huge difficulty in assessing the impact of the change. If you have to run new maintenance jobs, if your workload is going to increase for the end of the month batch processing, if you have to remove certain MIBs, throw in additional infrastructure, what is the impact of introducing this change is very difficult to assess. Most of the times this is done either through some basic intuition, past experiences, or at times changes are done and seen the impact and then they are reverted back if the change is not right. This leads to instability and also leads to a high business impact in a negative sense. So what are our aspirations? These are the three key pain areas we are trying to solve, and mapping each pain area to our aspiration, first thing you want to do is improve transparency, and that's what igneous batch capabilities tries to do. That we are trying to construct a comprehensive blueprint that cuts across business units, geographies, batch schedulers, environments, technologies, and gives a cohesive view connecting business units to business processes to batch jobs to underlying infrastructure. Secondly, every component that is blueprinted in igneous is profiled. Its normal behavior is analyzed using a whole heap of time series and graph mining algorithms. In order to deal with surprises, igneous comes with capabilities to eliminate risks and surprises. To do that, igneous comes with various levers. One is ability to automatically assess risks of each job, each business process, each dependency, and identify the components that are high-risk components. To do that, igneous comes with various approaches to derive risk of every job and comes up with a notification of the areas where one needs to take corrective actions. igneous also comes with a whole bunch of forecasting techniques by which it can predict future problems and give proactive notifications of the potential problems that are likely to come in near future. To provide ability to plan for business of tomorrow, igneous comes with automated virtual prototyping and what-if analysis capability, where you can throw in hypothetical what-if scenarios, and igneous can give you near real-time answers to the impact of those what-if scenarios. The key obstacles that we are trying to address while building these capabilities are as follows. There are some features that are unique to batch systems, and I find them worth mentioning while starting with the demo of this session. First is scale and complexity. We are not talking in terms of hundreds or thousands, where we are talking of hundreds or thousands or at times millions of batch jobs. And these jobs have complex dependencies across processes, feeds, files, hosts, different types of relation between workload, performance, resource, which kind of adds a lot of complexity. Another thing that is very unique to batch systems is changing environment. The batch graph of today looks very different from batch graph of tomorrow because different jobs are scheduled on different days of the week, different hours of the day. So a certain set of jobs are supposed to run only on weekdays, certain set of jobs are supposed to run only on weekdays, jobs are supposed to run only on first working day of the month, last day of the month, and so on and so forth. That's why each day's graph is very different. So you can't just do analysis once and use it forever. It has to deal with continuously changing environment. And diversity is another big challenge here, because now you are cutting across applications, business units, business processes. There are usually more than one schedulers that are used to manage these batch systems like outages, Control-M, TWS, OpCon, CS7. There are different platforms, mainframes, distributed systems, and of course different environments. So igneous comes with three main solutions. First is blueprinting and profiling. Second is eliminate risks and surprises. And third is plan for business of tomorrow. With this, I'm going to take you to the demo, and I'm going to show you how igneous is providing all these capabilities. So you're looking at igneous dashboard here, and first thing I'm going to do is I'm going to go into igneous Insights and show you igneous blueprint. So igneous blueprint is, first what you're seeing here is all the business units that are present in the environment. And every bubble here represents a business unit like NetBank, ILP Chennai, AWS Cloud, and so on and so forth. You click on a business unit, and you get to see all the business processes that are present in those business units. So in this, business processes are nothing but batch streams. Batch streams are like a set of jobs that are supposed to do a certain business function. So EOD Core Bank, DTTFT, all these are different batch streams or business processes, if you will. You click on a business process, and you get to see all the jobs that are present in that business process. Now, as you can see here, there are 271 jobs that are present in this business process. Naturally, no one wants to see a list of all the jobs present. What igneous does is, instead of just giving you a blind list of all the jobs, it provides these layers that I am showing you on the right-hand side. So there is a performance layer, there is a profiling layer, there is a risk layer. And when you turn on any of these layers, like I'm turning on the risk layer here, so these jobs get arranged into orbits. So out of 271 jobs that are present in this business process, igneous is saying that focus only on a select few jobs. So some of these jobs are put into the outermost orbit, which is representing the highest risk jobs. Then jobs are put into medium orbit, which are showing medium risk jobs, and then low risk jobs. So now next what I'm going to do is I'm going to click on one of the high-risk jobs, and I'm going to show you why igneous is calling it a high-risk job. So I'm going to go into risk management, and I'm going to give you an evidence of why igneous is calling that specific job as a high-risk job. So to compute risk, what igneous does is it looks at two aspects. First, what we call as probability of failure. How often does the job fail? How often has the job failed in the past or has shown any abnormalities in the past? So that's where the left-hand dial comes handy. where igneous is trying to show that in the past history, here in this case we had a history of close to 18 months. So in past 18 months we have seen this job fail 488 times. And we have seen 26 job failures, 82 max run alarms, 141 end SLA violations, and so on and so forth. So that is one dimension, that how often a job fails. Another dimension is whenever a job fails, how many other jobs or how many other business processes get impacted. That's the right-hand side of the dial, which is showing that whenever this job fails, 412 other jobs get impacted. And by the way, out of those 412, 56 jobs are business critical as well. So looking at both these dimensions, what we in igneo parlance we call as probability of failure and impact of failure, looking at both of these dimensions, igneo comes up with a risk score and identifies what are the most high-risk jobs. It also gives further some evidence behind the probability of failure. So like here it is showing the entire history of when a certain job failed, when a certain job led to end SLA violations, max run alarms, and so on and so forth. And it also gives you another view of impact of failure, that whenever a job fails, how many other jobs get impacted. So this is a view that shows up that whenever the orange job failed, all the blue and red jobs got impacted. An important point to note here is that the tree that you're seeing here got built by connecting different dependency informations cutting across different schedulers. So in this specific case, we had autosys dependencies, control M dependencies, and opcon dependencies, and all these were connected together to identify which all jobs and which all business processes are getting impacted whenever this job has failed. Note that we have highlighted some jobs in blue and some jobs in red. The jobs in red are the business critical jobs. So whenever a job fails and 100 other jobs are getting impacted and none of them are business critical, then that job is relatively low risk as compared to jobs where business critical jobs are getting impacted. So all those dimensions, all those factors are also taken into consideration while computing the risk score. Now let me take a step back and tell you that whenever we get a job or whenever we get any component, how do we profile it? How do we calculate its normal behavior? So whenever we profile any component that is blueprinted in Igneo is first profiled. And when we profile, we essentially look at three dimensions. Profiling of vitals, which are like all the performance metrics, all the workload metrics, all the resource metrics. Profiling of issues, which is all the events that we have seen on that component, and profiling of dependencies. So I'm going to first go into profiling vitals. And here, if you see, I'm going to go into profiling of runtimes. So when we profile runtime, we are typically seeing changes, trends, and outliers. Here you're seeing the time series of runtime of this batch job. And the blue line here that's showing up is historically how the runtime has been for this batch job. And what Igneo did is it detected that red point there, which is saying that I saw a change point at this specific point in time. Note that Igneo was not aware of any change tickets, any config changes. By simply looking at time series and by simply churning out data, it is trying to identify are there any significant changes here. Once that is done, then Igneo tries to identify are there any patterns here. So that's where it first looks at trends. That it is saying that in this specific case, there is a subtle decreasing trend, that the runtimes tend to be having a decreasing pattern. And then it looks at outliers, that are there any specific data points that are like significantly abnormal from the rest of the data. And those are kind of marked out as outliers. Another thing that Igneo does is it tries to capture are there any specific temporal patterns. So while finding temporal patterns, it is trying to look at is there a day of week pattern or hour of day pattern or first day of the month pattern and so on and so forth. So I took the same job and I'm showing you that Igneo identified that there is a day of week pattern for that job's runtime. The way to read this chart is that x-axis here is showing day of week and every blue bubble here is an instance of runtime that was seen on that day. So like if I take Mondays and you're seeing all these blue dots, so then these are all the runtimes that we have seen on Mondays historically over 18 months. And based on all the historical information, Igneo is deriving these red bars, which are showing the expected normal range of operation on that specific day of week, right? So based on that, what Igneo is saying that we are typically seeing very small runtimes on Sundays, very high runtimes on Mondays, and typically runtimes in the range of 2,000 to 3,000 seconds from Tuesdays to Saturdays. Let me give you another evidence of that, where this is a time series view, where what we are showing is blue curve is the actual runtimes that we are seeing, and red curves are the curves that have been fit on this blue curve to show that what is the expected range of normal behavior. Now, any data points that are crossing this expected range, like all the blue lines that are shooting over the red lines, are the true anomalies. All others are usually not anomalies, they are expected to be normal. A very interesting use case of this behavior that we have very often seen as part of ignore deployments is that this is typically used by folks to set thresholds for maximum alarms. Historically, maximum alarms have been set as static thresholds, that you just have a single value and that value is used to set your thresholds. That any time the runtime goes beyond 3,000 seconds, generate an alarm. And these static thresholds are not aware of the temporally changing patterns. So you have low values on Sundays and high value Mondays. These thresholds are agnostic to that fact. Instead of static thresholds, if you go with dynamic thresholds, the number of false alerts that you're going to get as part of maximum alarms or min-run alarms or a job not started and so on reduce significantly. In some of our POCs, in some of our customer engagements, we have seen these alert volumes reducing by as high as 70%. Especially in case of maximum alarms. Moving forward, so far I was showing you risk and profile. Now let me turn on another layer here, which is the performance layer. And now by turning on the performance layer, igneous is identifying only two jobs where it is expecting to observe performance problems in near future. I'm going to pick one of those jobs and I'm going to show you why igneous is reporting that as a critical job. So here I'm identifying the performance profile of that job, and this is what has been observed as part of this analysis. That igneous looked at the historical data and it observed that there is an increasing trend in the runtime of this job, and seems like if the trend continues the way it is going to continue, then this job is going to have relatively high values in the coming 3 or 6 or 9 months, and these values are going to cross the thresholds that have been configured. And that's why igneous is saying that it is seeing abnormally high trends in the runtime of this job, and it is giving notifications so that one could take corrective actions. So the interesting part is, out of all the jobs that are being analyzed, it helps you narrow down to select few jobs where problems are, and all this happens automatically. So when you log into igneous dashboard and turn on different layers, you can just get to the point notifications of problem areas, of insights, of recommendations, and so on and so forth. Going forward, so far I was giving you a blueprint, profile, and risk view. Now let me switch levers and take you into predictive analytics. So all the analysis that we did to historically understand a job behavior can now be used to predict future behavior of a bad job. So once you select a business unit, you can key in a future date here and just click on run analysis, and igneous can tell you how the batch is supposed to behave on that specific day. A very common use case that we see here is when people want to see how my batch is going to behave at the weekend, how my batch is going to behave at the end of the month or end of the year, or maintenance cycles, and so on and so forth. So you just key in the date, click on run analysis, and igneous will show you the prediction of that specific date. Here we have already kept a prediction of 31st December 2017, so we are going to show you that analysis. So what igneous first does is that it first gives you a business process view. So every blue bar here is representing one business process, and the way to read this chart is that every blue bar is showing when the business process will start, when the business process will end. So x-axis is time and y-axis is business processes. You can click on any of the business processes and it will show you all the jobs that are present in that business process, when they will start, when they will end, and so on and so forth. Next, what we do is we take you to the job view, and this is an interesting view that comes very handy for people to use day in, day out. A very common use case that we have seen people using igneous is that they schedule igneous to run predictions every night for the next day's batch. And when the next day when you log into igneous dashboard, you get a view like this, where you say that today 493 jobs are going to run. And if you see at the bottom, it is going to say that there are 21 jobs which will observe end SLA violations, 2 jobs which will observe start SLA violations, 2 jobs with maximum alarms, and so on and so forth. So that's the view igneous is trying to give. Also, the way to read this chart is every row here is a batch job. Unlike the previous chart, which was at a business process level, this chart is at a job level. And it is telling when a job will start, when will it end, and so on and so forth. You can click on various views here where you can say that, let's see the critical jobs. So igneous, out of 493, igneous is going to identify that out of 493 jobs that are going to run today, there are only 21 critical jobs that one needs to look at. And if you click on those 21, igneous shows you those 21 jobs. Why igneous calls them critical? Because they are defined as business critical and their SLA is expected to violate on this specific day. It also shows you by clicking on any of these menus on the right-hand side, on the left-hand side, igneous will show you when you will see end SLA violations, where will you see start SLA violations, and so on and so forth. And next, natural inclination is, so a couple of things here. So first thing is it shows you how many jobs will run. Next thing, it shows you where are you going to expect problems, which are our critical jobs. And the third thing that it does is it tells you which are the places where you should work on, where can you take corrective actions, and that's what is shown by critical edges. But a natural next question is that people want to see change impact analysis. That all right, this is the prediction, and now what will happen if I add job, if I delete a job, if I add a dependency, if I delete a dependency, if I change the runtimes, and so on and so forth. So that's where on any prediction, igneous supports the feature of what-if analysis. So as part of what-if analysis, igneous allows you to create different scenarios. So let me just show you how we create what-if scenarios. Here in this specific case, we first key in the name of a scenario. So I'm going to say that I want to add maintenance jobs. I'll just put some description there as well. And then we provide a whole host of levers. Like we can, you can create a complex scenario by making different combinations of these levers, like adding a job, deleting a job, adding a dependency, deleting a dependency, changing the start times, changing a run times. So let me just create a scenario here. So I will add a job. I'll specify the name of the job. I'll specify how long it's going to take to run. I'll put it in the queue. Now I'll throw in some dependencies there. So I'll add a dependency. I will explain where I will add a dependency from the job that I have added to some another job. I'll add that action. I'll create one more instance here where I will change the runtimes. Excuse me. Where I'll pick a node. I will change its runtime from 2.87 to, let's say, 50 minutes, and so on and so forth. So this is how you can create any complex scenario. Some of the very common what-if scenarios that our customers try to use is a what-if scenario to insert maintenance jobs, a what-if scenario to see the effect of increase in runtime of certain jobs, a what-if scenario to see the effect of delaying certain jobs from starting at a certain time to some other time, a what-if scenario to change the schedules of certain jobs, cutting certain dependencies. And all this can be done on near real time. So you just create a scenario, you execute it, and you see the effect of it. So here, I have already created some scenarios for you. So I'm going to pick one scenario, and I'm going to show you what that scenario is. We are going to add a job alpha 1. We are going to add another job beta. We are going to add a dependency between alpha and beta. And we are going to add a dependency between existing job and alpha 1. And of course, we are also going to throw in some other levers of changing start times and changing runtimes of existing jobs. This is a scenario that we have created, and we have run that scenario on the same date for which we had predicted. So like I predicted how my batch is going to behave on 31st of December 2017, and in addition to that, if I put in this scenario of adding 2 jobs and changing runtimes, I want to see the effect of that change. And that's where the what-if analysis shows reports, where the report looks pretty much similar to how the prediction report looks. But in addition to the standard predictions where we just say that 494 jobs will run, how many SLA violations will happen, it also gives you before-after scenario. So it shows you that 197 jobs will see the impact of that change. By clicking on those 197, the right dashboard kind of gets updated. And if you see, for every job now there are 2 bands. There is a before band and there is an after band. The brighter bands are the before bands and the dimmer bands are the after bands. So the way to read it is that if you see the first bar, we are saying that this job was originally running for a smaller time, but because of the Whatif change, now it is going to take longer time to run. And all other jobs are saying that originally they're starting at a certain time, but because of the Whatif, now we're going to start a little later in the scheme of things. Another interesting thing is it also shows you certain cases like the following. So if you see here, there are some cases where a job was marked as green before, but in the after state, it started getting marked as amber. The greens are the healthy jobs, and the ambers are the cases where you start seeing SLA violations. So we are seeing that certain jobs were not seeing SLA violations before, but because of the Whatif and Whatif scenario that you have put in, you will start seeing SLA violations. All right. Of course, in addition to that, the entire right-hand panel is also available where we identify which are the critical jobs, where are you going to see SLA violations, where are you going to see maximum alarms, and so on and so forth. All right. So yeah, another interesting thing is critical paths. So after doing Whatif analysis, igneous said that 26 jobs are critical because they are going to see SLA violations. It also identified that there are 61 paths which are critical. And if you click on those paths, igneous shows you the paths which are critical. And by critical paths, we mean that these are the paths where you need to act on to prevent these 26 SLAs from violating. With this, I guess this pretty much covers that I wanted to show in the demo. So let me now go back to my slide and cover 2-3 points before I open up for questions. So what are the key differentiators in this capability? One of the most important aspects is that this capability is self-learning. As I said, batch jobs keep changing constantly. So we can't just do analysis once and keep it forever. So igneous has self-learning behavioral models, and it constantly gets the data feeds and updates its forecasting models, its profiling models, its regression models. Second important aspect is accuracy. We have evaluated our prediction accuracies across synthetic data, across real data, across even customer engagements, and our accuracies have been as high as 95%. And over different experiments of sensitivity analysis, our accuracy range has been between 88 to 96%. So we have been very accurate, and that's one of the key points of batch prediction. And one of the biggest reasons to be accurate is the ability to do fine-grained forecasting. Third bit is predictive. So far, a lot of data analysis tools are reactive in nature. The ability to predict future with high accuracy, and in addition to that, give the facility of Whatif analysis makes a big differentiator here. And last but not the least is unified. igneous capability is not tied into one specific tool or one specific set of tools, but it has been designed to be generic that can work across different batch schedulers, across different environments. So if you have an environment which is a control M opcon shop, or if you have autosys control M and so on and so forth, so it can cut across different schedulers, take their data and do the analysis. Here is a quick view at one of the case studies just to show you how the product was deployed in real world and what kind of insights and benefits people were able to derive from it. So we deployed it in an environment with 52 business units, 2,500 business processes, close to 23,000 batch jobs, 100,000 batch job dependencies, and this was a control M opcon and legacy scheduler combination. So there were also some legacy jobs that were running through crons and so on, and these were SAP, Unisys, and legacy jobs. Some of the key findings that were like we were able to blueprint and profile 11,000 jobs. For 2,600 jobs, we gave recommendations for dynamic thresholds, and these thresholds were used to configure the alerting configurations for maximum alarms, minimum alarms, start SLAs, and so on. We were able to forecast future behavior, and for 750, we were able to generate 750 notifications of potential future problems that the environment was going to observe in another 3 weeks, 9 weeks. And also we identified 100 jobs which were high-risk jobs, which were taken up as immediate actions for problem management. Some of the key benefits that were derived from this case study was accuracies. The original accuracies were very low, close to like 70–75%. With igneous, we were able to give you close to 90% prediction accuracy. Because of our dynamic thresholds, the noise volumes were significantly reduced, close to 70% reduction in false alerts. And another big advantage was ability to reduce the time to transform. Typically in this environment, doing Whatif analysis used to take people 4 to 5 days. And with Igneo, we were able to do that job in minutes. So close to 70 to 80% reduction in time to transform. This pretty much covers what I wanted to show today. We are open up for questions. I would be happy to take.
Wonderful. Thank you, Maitreya, for that very informative presentation. Let's now move to Q&A. We do have some questions in the queue already. For those of you who have yet to submit a question, you may do so in the question pane in your console. Simply type your question in the question window and click send. Our first question for you, Maitreya, is what are the different job schedulers that Igneo supports today?
All right. So there are 3 schedulers that are supported today. We have support for Control M, Autosys, and OpCon. And in principle, any scheduler can be supported as far as the core capabilities are concerned. If there is any new scheduler support that we have to give, then the only thing we need to do is build an adapter that can take that scheduler's data and translate into the format that Igneo understands. So out of the box, we have support for Autosys, Control M, and OpCon, and we have some beta capabilities that support TWS and CA7.
Great. Next question. What are some lessons learned while building Igneo capabilities for batch jobs management?
Great question, Julie. And I would like to emphasize some of the points here. I mean, some very interesting points came up here while building these capabilities. And first one was that we realized that the core power comes by creating a comprehensive unified blueprint. It's important to cut across schedulers, it's important to cut across business units and geographies, and that's only when we can realize the true power of impact analysis or true power of predictions. And we can do that only if we have out-of-the-box support to quickly build adapters for any new technology. And that's where we have ability to quickly build adapters for any structured, semi-structured data. That's one. Second part that was a big lesson learned for us was our ability to self-learn. We realized that it's important to constantly update our prediction models or forecasting models and adapt them to all the changes that are happening. Otherwise, that comes with a big toll on our accuracies of analysis. Third observation was that pure analytics only generates interesting observations. It cannot give actionable recommendations. And hence, it is important to have a strong analytics augmented with a knowledge-centric design. It is important that the product is aware of batch as a domain, and only then it can give concrete actionable recommendations. So I will say those were the 3 key lessons learned while building this product.
Great. Next question. Can you please comment on IBM mainframe support?
Sure. So the way the product has been designed right now is that even if the batch systems are running on mainframes or distributed systems, it is tapping into the schedulers, the run histories, the job definitions, and that's why it is able to work on analysis of mainframe jobs as well as the distributed systems jobs. Having said that, the capabilities to analyze things like MIPS optimization, optimizing schedule to flatten MIPS, those capabilities are not present today in the product out of the box. We are building those capabilities and they'll be part of the next version. But everything that I showed you today as part of the demo works in mainframe environments as well.
Okay. Next question. How scalable is Igneo? We have large batch jobs in our environment across different BUs. How many jobs can Igneo handle?
All right. So Igneo is designed to work on a scalable platform. So we have a scalable compute fabric, we have a scalable data fabric, and it's actually designed to work at least on hundreds of thousands of batch jobs. The largest engagement that we have done is in the order of hundreds of thousands of jobs, and we have been able to support it fairly well.
Okay. Next question, how long does it take igneo to get to 70, 80, 90% prediction accuracy?
Yeah, that's a good question. I would like to emphasize this fact that the accuracy doesn't come to 90% on day one, because the accuracy is a function of how good or how detailed the data has been fed. So if on day one itself, igneo is able to receive past history of 13 months, the accuracies shoot up to as high as 80–85%. And after that, there is a certain learning curve by which the accuracies move from 80 to 90 bracket. But if on the beginning, igneo is fed data of just a week or a month or 2 months, then the initial accuracies are low, and only when it has seen sufficient enough data points to capture enough variations in the batch environment, the accuracies shoot up. In our experience, we need at least 3 months of data to reach an accuracy of 70%. For the jobs that are constant, whose behavior gets perfectly captured in 3 months, their accuracies go as high as 80–85% as well. So with 3 months, we reach the bracket of 70 to 80% with 3 months of historical data, not with after 3 months of deployment. If on day 0, we get 3 months of data, our accuracies are close to 70 to 80%. And over time, as we get more and more data, they shoot up to close to 85 to 95%.
Okay, next question, what data sources does igneo tap into?
Yeah, that's an important question. There are 4 main data sources that are mandatory for this. First is the dependency information, which is essentially capturing the job-job precedence relationships. These are available through the tables or by putting queries on control M's and outages and opcons of the world. So that's first. Second is we need historical information of the run history, where we need information about when a job ran, what was the start time, what was the end time, what was the run time, what was the status of that run, and so on. That's the second bit. Third bit is we need job definition information, which essentially says that are there any constraints on the start time of this job? What is the type of this job? Is it a command job? Is it a file watcher job? Is there a certain schedule of this job, that this job is supposed to run only on Mondays, only on weekdays, only on first working day of the month, and so on and so forth. And the last is threshold definitions, which says that are there any start SLAs, are there any maximum alarms, are there any end SLAs defined on these jobs. So these 4 are mandatory data sources. In addition to that, if we get information about the underlying infrastructure, the CPU utilizations, the workload information, more the better. So like for workload, if there are SAP jobs, then we expect the workload data to come from SAP systems. If it is mainframe, then we expect that the CPU information comes from the type 42, type 72 logs. If it is distributed systems, then we expect it to come from Linux or OS, any OS monitoring tools and so on.
Okay, next question. Can igneo perform analysis across different schedulers? And if so, how does it do it?
Yeah, that's one of the key strengths of igneo, that the product was designed to work across schedulers. As I said, the true power of impact analysis and predictions comes only when we have visibility across schedulers. So the answer is yes. And how? The key to how is to translate the models of control M and the models of autosys and models of TWS into a common model which can easily map any of these models into a single thing. So that's the key idea. Build a unified model and map all data sources to the igneo model.
Great. Next question. Can you give me some examples on what types of what-if scenarios are supported?
Sure. So there are 3 styles of what-if scenarios that we support. First is operational changes. These changes are like adding or deleting a job, adding or deleting a dependency, changing the schedule, changing the runtime of a bad job. Probably I'll kind of split it further. So one are changes related to dependencies, that you can add delete jobs, you can add delete dependencies. Another is changes related to performance, that you can increase or decrease runtime of bad jobs. And third is changes related to schedules, then you can start a job early, you can start a job late, and so on. So these are the levers, and you can make any combinations of these levers. So as I said, the typical examples of what if scenarios are effect of adding maintenance jobs, effect of throwing in extra MIPS, effect of having an increased workload, effect of running a certain set of batch jobs a little late or little early. All these are supported out of the box.
Okay, next question. I don't understand, how does Igneo predict a future batch?
Yeah, so prediction of future batch is an interesting combination of graph analysis and time series analysis. So there are a couple of things that happen there, that when you give a future date, Igneo first identifies which jobs are supposed to run on that date by reading the schedule definition. And once that information is known, Igneo uses the past prediction models to predict the future behavior of each batch job and create the prediction of the future day's batch. And lastly, once that prediction is available, then Igneo maps those predictions to the SLA definitions to identify which are the SLAs that are likely to violate. And while doing this analysis, Igneo is using this workload information and runtime information and using underlying queuing models to essentially see the impact on underlying infrastructure and the performance. So yeah.
Okay, next question. Lots of questions in the queue. Like most people, I have too many batch jobs. Can Igneo pinpoint a select few jobs that are high risk and need to be acted upon immediately?
The answer is yes, and that's also one of the core design solutions that we had, that the product should be built that has a point of view. We didn't want to build a generic exploratory product. The idea was to develop screens which can help users pinpoint to actual problem areas. And this is very important given the scale of batch jobs. When you have hundreds of thousands of batch jobs, you really don't want a tool that just gives you an exploratory view. So yes, with the concept of layers, you can turn on, turn off certain layers, and Igneo can help you identify what are those key jobs that one need to look at. And there are different layers, that what are the key jobs with respect to risk? What are the key jobs with respect to performance problems? What are the key jobs with respect to future SLA violations, and so on.
Great. Next question, while building cognitive capabilities, what properties of batch systems makes them unique?
Another interesting question. Batch systems are unique in various sense from traditional IT systems or any transaction systems, if you will. One of the biggest differences is scale. We are not talking of 100 application servers or 1,000 database servers. We are talking of millions of batch jobs. And the dependencies are also very unique, that there are precedence relationships, which is a very unique property to batch jobs, that certain jobs cannot start until certain other jobs have finished. Another thing that's very unique to batch systems is changing environments. A batch graph of today looks very different from the batch graph of tomorrow. And that is because not all jobs are scheduled every day. Certain jobs run on weekdays, certain jobs runs on weekends, and so on and so forth. And third is heterogeneity, that in many organizations, because batch systems are running from like decades, 20 years, 30 years, 40 years, so there have been progressions, but there are some legacy jobs, there are some legacy schedulers, and there are new schedulers, and there are very new schedulers. So it's important to build a product that can cater across all these legacy jobs as well. So these three things, I guess, make batch systems very unique.
Okay. Next question, I get a large volume of noisy max run alarms. Can Igneo recommend optimal alert configurations to reduce noise levels?
Yes, the answer is yes. When I was explaining the event management capability, I was showing you how those max run alarms are set, how dynamic thresholds are computed in Igneo. So those can be used to essentially capture, are there any temporal patterns, and if there are temporal patterns, then what are the dynamic thresholds that can be set for those temporal patterns. So essentially, Igneo profiles past history, and based on that profile, Igneo comes up with recommendations for max run alarms. So by doing that, I mean, one of the big selling points there is that instead of traditionally people only use static thresholds. So if you can see my screen here, instead of using traditional static thresholds, if we recommend dynamic thresholds that set low thresholds on Sundays, high thresholds on Mondays, and medium thresholds on Tuesday to Saturday, that can significantly reduce the noisy maximum alarms that you get.
Great. Let's go ahead and take one more question because we have gone over on time. How about, in your experience, has Igneo brought up any unexpected findings to the batch team, something that the team was not aware of before implementing Igneo?
Lots of them. Starting with the blueprint itself. So when we created blueprint connecting schedulers, or even within a scheduler, we started seeing gaps. That there were duplicate entries, inconsistent dependencies, there were gaps, the gaps between schedules and job definitions and run histories and so on. So while building blueprint itself, there was a lot of course correction that happened, and it helped people identify the problems in the way their schedulers were working. That is one. Second not so obvious finding that came out was our recommendations for identifying high-risk jobs. Because the impact analysis is usually not known, when Igneo computed probability of failure and impact of failure and computed risk scores, many jobs got identified which are otherwise not considered to be high risk. They started getting noticed at high-risk jobs. Another interesting insight which was found non-trivial by many of our customers is our forecasting models. That the kind of proactive notifications Igneo gave with high confidence that in next week these problems are going to happen, in next month these problems are going to happen, were not expected or they were not prepared for those. So that was a non-trivial, those were some of the non-trivial findings as part of analysis.
Great. So we are out of time, so that's going to conclude our webinar for today. I know that there are some questions in the queue that we were not able to get to, so if we were not able to get to your question, we will reply to you individually offline. If you are interested in a demo or if there are other questions that we can answer, please don't hesitate to email us at contact@digitate.com. That's contact@digitate.com. Thank you so much for joining us, and we wish you a wonderful rest of your day.